Hello everyone, welcome to this video where I'm going to walk you through from scratch, step by step, a full project in Python where we're going to be doing some customer retention analysis. So we do have some real world data here. I'm not going to disclose the company just for data privacy reasons. And let's take a look at our data. So it's in this Excel document where we have three sheets. We have a user registration table, a mobile orders table, and an in-store orders table. And all three of our tables here are in the same Excel document, which will make it very convenient to bring these into Pandas data frames. So our user registration table is simply just user IDs, just one is unique for each customer, and whether or not they are a premium subscriber. So we have premium subscribers and we have non-premiums, which we're going to refer to as free. So we have mobile orders, so same thing. We have a unique user ID, which is tied to a customer, and the total number of mobile orders that they have placed in their lifetime. And the same exact thing for this in-store orders table. It's just this time it's going to be in-store orders rather than number of mobile orders placed. So let's bring in import our libraries. Mainly we'll be using Pandas. I'm importing NumPy here. We actually don't use it, I believe, in this project, but it's always good to have it just in case you want to run some extra calculations. And then we're going to be using Plotly to visualize our data in terms of a customer retention curve at the end. So we're going to want to break down what percentage of our customers are purchasing a certain number of times based on differentiating between premium versus our free customers. So we have our libraries, and now we're going to get started by bringing in our first data frame. So we'll call this users equals pandas.read Excel. We're going to want that user registration table. I have my Jupyter Notebook and that Excel file in the same folder, so it'll make this easy. There's our file name. Then we need the exact sheet name. Let's pull that in from Excel. And let's just get a random sample of, say, 15 records. And this is going to take a few seconds to run here, as this is a data frame with thousands of customers. There we go. So a bit of background on this table. This is the current snapshot of users who have registered a profile with our company. So if a user, let's say, had registered in the past, but then deleted their profile, it's not going to show up in this table. This is just a current snapshot of all the customer registrations that we currently have, then their corresponding status as either a premium subscriber or a non-premium subscriber. So as always, it's just a good practice to do some quick EDA and some data quality checks. So see the number of rows we have. So we have 201,000 and change rows. And let's check for null values. No null values, which is nice to see. And now we want to make sure that all of these 201,217 user IDs are unique. So we have no duplicates. So we can do that like this. Say that number unique. So that'll show us the number of uniques, and then we can create a Boolean, just say equals the length of the data frame. So say dot shape index 0. We got our S there, and that's true. Just for reference, another way to actually confirm this is we can do it like this. So users and we can use the duplicated function. We can take the shape to see the count, and that should be 0, and it is. So that just confirms it. And now let's take a look at our categorical binary field here is subscriber. So users is subscriber. Let's do dot value counts. And even though we know there are no values, it's always just a good practice in this value counts formula to set drop NA equals false, just so you can see how many nulls you have and make sure you're not missing anything. So we have an overwhelming majority of our registered current customers are the non-premium or non-subscribers here. So we have about 1,500 compared to almost 200,000. So we can normalize this. Let's make it a percentage. So round it 100 times that, and we'll leave 2 decimal places. So at 99.21% free versus just 0.79 premium customers. Actually do is just visualize this just to give you an idea. Get rid of that. Let's say dot plot. The kind of graph is going to be a bar. And there's our graph. Okay, so moving on to our mobile orders table, we can use that same template code since it's coming from the same Excel file. And let's replace the name. We'll call it mobile. And then let's make sure we get the right sheet name. Needs to be an exact match. And this should take a few seconds to load as well, since it also has tens of thousands of rows. And there's our data frame with 15 random samples. So this is just a unique user ID and the total number of lifetime mobile orders that have been placed. So if a user ID appears here, it just means that that user has placed at least one mobile order. It is possible, as we'll see in a second, for a user ID to appear in this table, but not in the user registration table, which we can infer as meaning that the user ordered, but then later deleted their account. So let's do some quick, again, EDA and data quality checks. So we can say mobile dot shape, 141,690 rows. Let's check for nulls. No null values. And then let's make sure every user ID is unique. We can pull that code from up here. And actually the name of the column user ID is different. So we'll fix that later on, but just to make sure we get that right here. And the data frame is called mobile. And we have no duplicates. So now let's take a look at our our numerical field here, mobile orders. And let's get an idea of what the distribution looks like. So we can do that first with some descriptive statistics. Let's go mobile orders dot describe. Our count, then our mean. And then importantly here, this will really matter when we go to join our tables, but the minimum is 1. So minimum mobile orders is 1. Let's make sure that the data type is an integer here. So we shouldn't have half an order anywhere. So mobile dot data types and integer. That's what we want to see. So that means we can assume here, in order to appear in this mobile orders table, the customer must have ordered at least once. So we don't have any zeros in here. And so this mean we can interpret as of all customers who have placed at least one mobile order, the average customer has placed 9.56 of them, 9.57 with some rounding. And now let's get an idea of what the distribution looks like. So we can use dot plot again. This time we want a histogram because this is numerical. And we can already see from the statistics here that, so we have the median right here. 50% is 4. The mean is like about 9.5. So this is going to indicate that this distribution is skewed to the right. And we can confirm that by graphing it. And let's get some more bins for our histogram. Let's say 130 of them. And we'll fix the range so that we can see this a little bit better. From 0 to, let's call it 100. We can zoom in a little more, let's say to 50. And that gives us a good idea of our distribution. So, like we suspected, skewed to the right. And the last thing we want to do here is figure out which of these customers have placed mobile orders but do not appear in the current registration table. So that would indicate users who have ordered in the past but then later went on to delete their accounts with the company. So we can do this by saying mobile, put that into a filter, and then mobile user ID column, say dot is in, and then users user ID. So this would show the IDs that are in that users table. We want the ones that are not. So we're going to make this the opposite. So not in, pass our little squiggly sign here, which means not, and run that. So these are all the IDs that don't show up on the registration table. So we'll say just dot shape 0. Whoops. So 1,827 users that we know of who have deleted their accounts. And let's actually get a list of those user IDs so that we can send those over to our marketing team and have them target those customers to try to bring them back to the company. So let's delete that. And then we can pass through .loc and then the column name, which is going to be user ID. That's a series. Let's make this a list. And there are our deleted user IDs. So now let's bring in our in-store orders table. We'll pull that same snippet of code. And we'll call this DataFrame in-store. I believe the sheet name is in-store orders. So we'll find out in a second. That looks good. And then we're going to do the exact same, just data quality and EDA checks that we did for our mobile orders table. We get our number of rows. Check for null values. None. And then look for any duplicate IDs. Just forgot our column name there. That's what we want to see. And now let's take a look at the distribution of our in-store orders column. Descriptive statistics. So the mean is a little bit higher. Let's make sure we have an integer format. Perfect. And so same thing here. In order to appear in the table, the customer must have placed at least one in-store order. And the same thing goes for, this is historical orders. So even if the customer later deleted their account, it's still going to show up in this table. And so let's do another check for deleted accounts. We can pull the same line of code here. Oh, and actually, we forgot to visualize the data. We can do that first. Always a good idea with any data set. Say about 200. Looks like the mean is, yes, the mean is a little bit higher here. Also skewed to the right. And there's our distribution. All right, so now let's check for our deleted IDs. Just adapt this line of code with our new data frame. That should be good. And there's our list. Let's just check the length of the list. So 651 of them. Then we will send this list again over to our marketing team. So now we can get into some data frame manipulation, which is going to be the real meat of this project. We're going to take our data and we're going to get it ready to be visualized in a nice customer retention curve. So first, I think to make this a little easier, I think our users table, yeah, so our column name is spelled differently than the other user ID column names. So let's fix that here. Just for simplicity, when we go to join our tables, so it's a users.rename. And we want this to be in place. And then again, for clarity, I also want to replace this is subscriber column with like a user category column where we define the registered user as either premium or free. So we can do that with a list comprehension. So we'll call it new column user category equals, and then user is premium. If I is going to refer to the value in this column. If I equals yes, else we'll refer to them as free for I in the is subscriber column. So that is going to be users subscriber dot values. Make sure this went through. That looks good. Then we can actually drop our is subscriber column. So we'll do that. And that all looks good. We can just quickly check to make sure our list comprehension worked. We'll just do a quick value counts here. And perfect. Okay, so now we can join our tables together. So pandas.merge. Our left table is going to be users, the right table, either one of the orders tables, doesn't matter the order here. It can be start with mobile. And then we want to do a left join. So for the purposes of this project, we really only care about the currently registered users. So we want to maintain all of those user IDs that occur in that registered users table. And remember, if we look at our descriptive statistics up here, customers who have not placed any orders are not going to appear in the orders tables. So if we have customers who are registered but have not placed an order, then with this left join, we're going to get null values. And that's fine because we can make the assumption then that we can fill those null values with a 0. So we're going to use a left join, and we're going to join on the user ID. That looks good. And then we can just take that and then join it straight to the in-store orders table. And then same arguments here, keep the left join to maintain those registered user IDs. That looks good. And so now we can define a new data frame. We'll call it orders. So we expect to have some null values here. Let's make sure. It's an A dot sum. So none for user ID, user category. That's fine. We do have some nulls here, and that essentially means that we have 61,354 currently registered customers who have never placed a mobile order, and 149,484 currently registered customers who have never placed an in-store order. So let's actually go ahead and fill those values with a 0. And just to avoid hard coding, which is a good practice, we'll put this into a for loop. So we can say for call in orders dot columns, and then we want, this is index 1, sorry, 0, 1, 2, so we want 2 and onward. Orders call is equal to same thing, dot fill NA, and we want to fill them with zeros. And that all looks good. So one kind of annoying thing about joining sometimes in Pandas is it'll take your integer values and it'll turn them into floats, which looks like has happened here. Let's check. Yeah, so these are now floats. Object is just fine. That's just another word for string, which is what we want. We'll change those to integers in a second. But first, for the purposes of this project, we actually only care about the total orders placed. So we're not going to differentiate between how they were placed, between mobile or in-store. So let's create a new column. And we'll call it total orders. And it's just going to be the sum of mobile and in-store orders. So orders, mobile orders, plus our in-store. And then we're going to want to make sure that this column is an integer. So say dot as type, we want int. And then let's just print out our data frame. Always good practice to make sure that looks good. And then we can actually just go ahead and drop these columns, which we won't be needing them anymore. So our data frame, and then we can go ahead and make this in place. Let's take a quick look at our distribution of total orders. Just say dot describe. Okay, so now we can kind of move on to our next step here. So we have our orders data frame. And we want to figure out, we just start figuring out whether or not each one of these customers has placed at least a certain number of orders. So we want to start essentially generating kind of a customer retention curve. So, and we also want to make sure this is broken down by user category here. So to demonstrate how this is going to work, we can kind of create, start to create almost like a manual for loop, like so. So we can say orders, and then we want it broken down by user category. So this little filter. And just for now, we'll just look at the free customers. And we want a second criterion here. So put this in parentheses and say, and with the parentheses, we want total orders. We'll say greater than or equal to, let's start with just 1. Then we can say dot shape to get the number of users who fit this criteria. So this is basically saying that we have 150,055 currently registered free users who have in their lifetime ordered at least 1 time. So now let's get this in terms of a percentage of currently registered free users. So we say divide and put that on the next line. And a couple ways to get this number, but we can do it. So we can do it like this. So orders category equals free. Same thing here and here. So we're comparing apples to apples. And this is basically just going to create a series of Booleans. So we can take advantage of that by saying dot sum. Should give us a percentage. We'll do times 100. So we know that 75% of currently registered free users have placed at least 1 order in the company's lifetime. And then we can start kind of playing with these variables a little bit. So let's create a variable, just call it cat. So this is equal to free just for now. And then we'll say min orders equals, and right now we have it set to 1. So now we can go back into our line of code here and replace these. We'll call this cat. We'll call that min orders. Cat goes here as well, the same output. And so we can start to play with this. So we know that 100% of our registered users have ordered at least 0 times. Obviously, that's just logic. Then we can start to increase this number. So down to 64% for 2. Let's go to 5, keeps going down. Go to 10, it goes down a little further. You go to 100, goes down even further. So you get to see here, as we start playing with our minimum orders, we start increasing it. We're going to create essentially a user retention curve where minimum orders is going to be on our x-axis and the percentage of currently registered users in the specific category that have ordered at least that number of times is going to be on the y-axis. And we want to do this for both free and for premium. So same thing, it'll be 100% for 0, and then it'll start going down. So now 73% for at least 2 orders, say 10. We keep going down. So you see it's a little bit higher for the premium users, which is to be expected. And one of our goals here with this project is to see just how big of a difference premium versus free is in terms of the number of orders that these customers are placing. So say 100, we're down to 12%. And let's see how long it takes to get this number below 1%. 500, we're down to 2, 800, 900, 1,000. So now we're finally under 1%. So you can see that this lends itself very well to not just the graph, but also in a for loop. So we can test out a bunch of values here for this minimum orders, and we can do it for both the premium and the free users. So let's do that. So we're going to create our list of the different order bins that we want. So let's call this, yeah, we can just call it, oops, we can call it order bins. And we want starting at 0. We want to make this very, very smooth. So we're gonna run a lot of order bins through here. So we get a nice smooth curve. And we'll go to 1100 just to be safe. Let's take a quick look at our orders table again. And now we can start to create our for loop. So what we want to do here is create a new column for each one of these bins. And it's going to be binary. Each one is going to be binary, essentially saying whether or not each one of these customers has ordered at least X number of times. So we're going to have, let's see how long this list is. When order bins, so 43 new columns for each user. Now, this is how we're going to build out this for loop. So we can say for, we'll call it order bin in our list called order bins. And we're going to have a list comprehension within our for loop so that we can iterate through each one of our customers. So we're going to create a bunch of new columns. So we'll call it, say, orders, and say we'll call it orders greater than or equal to, and then we need to concatenate here so that we have a new column that has a name changing depending on our bin that we're referring to. So concatenate, we cannot concatenate a string and an integer here. So let's manually change this to a string so that we can concatenate that. And that will be the name of each column. And so we want it to be binary. So 1 if I, and I is going to refer to our total number of orders here. So if I is greater than or equal to the order bin, else 0 for I in our total orders column. So orders total orders dot values. And you can put this on the next line to make it nice and clear. And let's print our data frame, make sure this works. It'll take a second to run because again, it's looping through a lot of different values here in our data frame, and there it goes. That looks pretty good. We want to get rid of this this dot 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 here so we can see all our columns, make sure everything worked. So let's do that. So pandas dot set option. Display dot max columns, and we want no max, so we'll pass through none. And then orders dot, let's just get the first 10 records. Okay, so now we can see all our columns. That looks better. And let's just look through and make sure this worked. So our first customer has not placed any orders. So we have a 1 there and we have zeros everywhere else. So orders greater than equal to 0, every single customer has ordered at least 0 times. Obviously, that's just logical. So every value here in this column is going to be equal to 1. So 5, so we should have a 1, 1, 1, 1, 1 up to 5, and then 6. Starting here, we have zeros. That looks good. Let's look at one more. So we have 31. So we have 1s all the way up to 30, and then it fails at 35. So this looks perfect. And now we can move on with the next step. So what we can do here actually is we no longer need our user ID, and we actually don't care about total number of orders anymore now that we have our bins. So we really just need our bins and we need the user category designation. So you can say orders.drop columns equals, so user ID and total orders. And let's make this a brand new data frame. We'll call it totals. So now, because we have a bunch of binary variables, we can take advantage of that by aggregating based on the user category. Because remember, we want to differentiate between the free and the premium. We want to compare those two types of customers. And we want to find out the number of each of those types of customers who submitted at least 0, 1, 2, 3, 4, and so on number of orders. So let's put that into a group by here. So we can say totals dot group by on a group by user category. And then we want to aggregate on all of these columns. So what we can do here is say totals dot columns, and we want everything except for this first one here. So we can say index 1 and on. Those are all of the columns we need. So copy and paste that into our group by, and then we want the sum. Let's reset the index so that we have this user category column out of the index and into an actual column. That looks good. And then we can overwrite our totals data frame. So now we have this very short but extremely wide data frame. And so what you'll notice about these columns is we really only have 2 types of them. We have the user category, and then we have the bins. So these bins are really, it's really the same information. It's saying the minimum number of orders that were placed. So what we want to do is we want to unpivot this data frame and make it tidy, or melted is another word, so that we have one column for the user category, and then we have one column for the minimum bin here, and then we'll have another column for our values, which is going to be all of these numbers. So this will make it a lot easier to graph it later on. So what we want to do is we're going to pass through pandas.melt. It's a very useful function for stuff just like this, for unpivoting your data frames. And our data frame is called totals. The ID vars, those are the columns that we don't want to pivot. And so we want to keep the user category in place there. And now we want to collect all of these columns here. So we're going to pull this same snippet of code here. So all of the columns from index 1 and on. And that is going to be set equal to the value vars argument. And then we can name that variable. So we can say var name, and let's call it orders bin. And then we need a value name as well for what we're going to call all of these numbers. So we can call that registered users. And that looks good. So now we just have a nice tidy data frame with our user category, a bin. So we're going to have one bin for each of the free and then premium, and the number of registered users who meet that criteria. And we can create a new data frame here. Let's call this, since we have our melt function correct, we'll call it graph data frame. So now remember, we don't want to compare the raw total number of users. We want to show this as a percentage of registered users. And for that, we need to pick a baseline number. So let's say, for example, we pick, let's say baseline is equal to 0. So we're essentially picking a denominator here to create the percentage. So baseline equals 0 would mean that this is going to be the baseline number for free users. And this is going to be the baseline number here for our premium users. So that would be essentially saying, using these numbers as denominators, that X percentage of all currently registered free users have ordered at least a certain number of times, and then the same thing for premium. Now, let's say we change the baseline to, say, 1. So then our percentage, the interpretation of our percentage would change as follows. So then it would be of customers who have ordered at least once, X percent have ordered at least 2, 3, 4, and so on times. So, and we can play around with this baseline number depending on the kind of curve that we want to show. So let's actually start with 0 for now. And now we need to create a new column to bring in that denominator. So baseline of 0 means if user category is free, we want our denominator to be this number. If the user category is equal to premium, then we want it to be equal to this number here. So the way we're going to do this is we can say, before we actually create our list comprehension, we can demonstrate how this is going to work. So we're going to want 2 criteria here. So first, that, say, graph data frame user category equals, say, free, just for now, but that value will change once we use our list comprehension. And that the orders bin is equal to our baseline. So, say, parentheses, graph data frame. And now, so you'll see right now with our orders bin column, we don't have a number. We need a number to compare this baseline to. So before we actually run this line of code here, we need to create a new column for the minimum number of orders in order to meet this criteria here. So we want to pull out these numbers at the end of our strings. And we can do that with the .split function. So we can say graph.df, and we'll call this column and say min orders. And this is equal to I .split. In this case, I is going to refer to the values in our orders bin column. And we want to split it based off greater than or equal to space here, because we know right after greater than or equal to space, then we're going to have the number. So string greater than equal to space. And what this .split is doing is it's actually going to create a list of each value in the column, with the index 0 of that list is going to be everything that comes before what we're splitting it on. So this right here. And then index 1 is going to be everything that comes after. So just the number. So what we're going to want is we're going to want the index 1 or the second piece of that list. And we also want this to be an integer, not a string. So let's wrap this in an int function. And this is going to be the value of our new column. And this is going to be for I in graph data frame orders bin dot values. And that looks perfect. And then we can go ahead and drop our orders bin column. So now we have a column to compare our baseline to. So we want this min orders column to be equal to 0. And we're going to put that right into here in our line of code. So min orders, and we'll set that equal to the baseline. So we just used a filter here, not a .loc. So we're going to get all these columns. So let's add in .loc. And we only want the registered users column. Clean that up a little bit. And this should return a series, even though it's only going to be one value. Yeah, so it's only going to be one value, but we want this to just be a number, not a series. So we can do a couple things. We could do index 0, that'll work. We could also, probably the safer option is say .max, and that'll give us our number. So now we want to put this into a loop. So we essentially want to say that if the user category is free, then we're going to get this number. If the user category is premium, then our new column will be this number. So let's call this new column, what do we call it? Graph df, let's say category totals. This is going to be our denominator. So to get our percentages, we're going to divide registered users by category totals. And we can put that onto the next line. And then this is going to be a list comprehension. So just adapt this line of code here. And this is going to change to an I. And this will be for I in graph data frame and then user category. It's a little messy there, but this should do the trick. Let's run that code, see if it worked. And that looks good. So perfect. So you'll see every single customer has ordered at least 0 times. So these numbers are going to be 100%. So where the baseline is set, our percentage is going to be 100. So now let's actually create our percentage. So it's going to be registered users divided by category totals. And let's see, we can call this, call it percent registered users. And that is going to be equal to, we can use a for loop, or not a for loop, a list comprehension. Say graph df. Actually, let's see if we can just divide it. I'm not actually sure. Let's see if this works. Yeah, looks like it works. And that is perfect. So now we can go ahead and drop our orders bin column. Actually, sorry, we already dropped the orders bin column. We can just go ahead and drop our category totals. We won't be needing that anymore. And actually, I think we can even drop our registered users column as well. We should be able to. We can always come back and fix it if not. All right, and that looks good. We can overwrite this. And now we have our final data frame that we are going to use. And now we are ready to create our customer retention curve. So we have our user category. That's going to be, we're going to create two traces, one for our free customers and the other for our premium customers. So two curves. And then this is going to be our x-axis, so minimum number of orders. And then this is going to be our y-axis, so percentage of users. So this is where we're going to use our Plotly package to visualize this data. So, and I highly recommend going on Plotly's website. So Plotly is my preferred library for visualizing data. And you'll see why in a second, but the code is a little bit more complicated and it can be hard to memorize. So I really recommend going on Plotly's Python website. They do have libraries for other languages as well. So make sure you're on the Python website and you can really study this code and get it right with a lot of detail. So our fig is go.figure. And then we want to add a trace. So this is first going to be adding, we can add our free customer trace first. Fig dot add trace. And then we want a scatter plot. So go.scatter with a capital S, can be a little confusing sometimes. But again, just go to the website and you can get your code right. So X is going to be equal to our graph data frame. And we only want, this is only for our free users. We're going to create a second trace for premium. So this is going to be graph data frame where the user category is equal to free. And then we want to select our min orders column up here. So let's say dot loc and then min orders. Make sure we fix that. That looks good. Now we can set our y-axis. And it's going to be the same thing, except we're going to use the percentage of registered users column instead. So our user category is free. Let's close that off and then say, let's make sure we get our column name right. And then let's name our trace here. So select name equals, and let's say free customers. down here and say fig.show, just see our progress. And this is our curve. So the beautiful thing about Plotly here is you can hover over your visualization, and it's actually going to give you a little hover template. So it has a bit of an interactive function that if you use something like Matplotlib or Seaborn, very easy to use, but it just doesn't have the same features. So personally, I prefer to use Plotly. And rather than, we can do the same exact thing here. So just add another trace, except now we're going to say this is premium and premium here as well. Premium customers, and this should give us a second trace. So there's our premium and there's our free. But I always like to avoid hard coding if possible. So instead of actually just manually putting in these two traces, I would rather kind of future-proof this graph and create a for loop here. So this is how we're going to do it. So let's shift this over, make room for our for loop. And let's say for I in graph data frame, we're subbing in the different user categories. So user category dot unique. That way in the future, if we have any other user categories that we want to differentiate on, our code will automatically update with this for loop. So now we need to switch this out for an I. And same thing with this. And we need to concatenate our string here. So say I plus customers, and that should work. And that looks good. Okay. And now the rest of the work here is really just going to be making this graph look as professional, clean, and interactive as possible. So this is where, again, going on Plotly's website and pulling in code is very useful. So the first thing we're going to do is we're going to institute a hover template. So we want these values to show up as percentages. That's actually one of the things we'll do. Actually, we can update the mode of the graph first. Let's do that. So we can say fig dot update traces. Mode equals markers plus lines, and this is gonna give it's gonna put points onto our line here. So now we have all of our points. And then I want to change around the hover template again. So I'm not big on this format here. We're going to switch that around to something called X unified. So fig dot update layout hover mode equals X unified. So now this is much cleaner. So we can actually see both the free and premium on the same hover template there. So that's my preferred hover template for graphs like this. Let's actually change this to, let me just change that to users. Hopefully that'll fit on our hover template. That looks better. Okay. And then let's add in some axis and graph titles here. So we can say x-axis title equals, and we want, call this minimum total orders. So now we have that access title. And then we can pass through the same thing for the Y access title. So that equals, let's say, percentage of registered users who ordered. Now let's concatenate in our baseline here. Because again, we're going to change this baseline in a second and change up our graph. And we want to build in, we don't want to hard code this in. So let's say plus baseline. Remember, our baseline is 0 right now, and we need this to be a string. So 0 plus times. Let's see if this works. That looks good. And we also want to change, we want to change this y-axis to a percentage because currently we have decimals. We'd rather have a percentage. So rather than just saying y-axis title, again, this is just Plotly's syntax here, but we can change this to y-axis. Now we pass a dictionary through here. And this is going to be equal to the title. So this is the title, colon, and there's a string. So this should give us the same output. That looks good. And now we're going to pass another key in the dictionary, and we're going to call this tick format. And this is the format to turn our axis labels into percentages. So tick format, colon, and here's our string. So it's going to be a comma dot 0, the 0 meaning rounded to the nearest integer. So we don't want any decimal places, and then a percentage. And now we have the percentages on the y-axis title. And now I want to do the same thing with our hover template there. So I want to change these to percentages. Actually, one nice thing about Plotly here, it does it for you, but I want some decimal places here. So let's go in and do that. So we can specify a hover template. Let's in the next line. And let's put our numbers in bold. So the way we do that is this is starting our bold. Now we need our variable. So it's going to be our y variable, colon for the formatting, and then dot 2. So this 2 is going to be to the nearest 2 decimal places. And then we want it to be a percentage, and then close bold. Right. So let's see if this works. And that looks good. Okay. So in bold, we have our percentages, the nearest 2 decimal places. So now let's give our graph a title, and that is going to go in the update layout argument here. So we can say title equals, and this is going to be a dictionary. So we're not just going to want to give it a title, we're going to want to give it a title and be able to place the title centered right here on top of the graph. So the title text, oops, we have to start a dictionary first. Text is going to be, let's call it retention curve for free versus premium customers. And let's just see what this looks like. So our title is up here as the default. We want to bring it just right on top of our graph and nicely centered. So we're going to pass through some other keys in our dictionary. So we can say the Y of the placement of this title. Say Y equals, let's start with 1, let's see where it ends up. Oops, it's dictionary, so :1. And then our X will go center at 0.5. We can play around with these depending on where our title ends up after we run this. And then we want our X anchor to be centered. So center. And then Y anchor, we'll set that to, say, top. See what happens. This comes up here. Let's change this around. So bottom, oops, disappears. Middle, I think we're just gonna have to bring down our Y coordinate here. So 0.8, a little bit higher. We'll go to 0.85. That looks good. Now I think we need to move our X over a little to the left. Say 0.45. That looks much better. Say about 0.47 or 0.65. That looks good. And now finally, let's go ahead and adjust our X-axis and Y-axis ranges here. So you'll notice with Plotly, this is the interactive feature is what makes it so good. But not only do you get the hover template here, but you also have the ability to zoom in by clicking and dragging. So let's say I only want to look at, I can say from like 80 and below. So click and drag, and we can zoom in on the graph, and then just double click to reset it. But we're going to go ahead and just set our X range down here. So we can pass through big dot update X axes. I'm going to say range equals, this is where we can bring in our baseline again. So let's say range, it can go from our baseline, which is 0, to, let's say we want, let's say like 200. So that's a little bit more zoomed in. And actually we can come up here and we can set another variable. We'll call this max X val. We'll say, if we set that again to 200 for now, we can put that right in here. And so you can see how this these options are suited very well for a dashboard, where you can allow the user to play around with the baseline and the max X value. The downside to using, there is Plotly Dash, and I have created some dashboards in Plotly Dash before. The downside is it can be very difficult to share with other people. So whereas, which we'll see in a second, we can download this graph as an HTML file and maintain these nice like interactive features. In Plotly Dash, you can't just download the app. It has to be run on your computer. So if you send your code to someone who doesn't use Python, doesn't use Jupyter Notebook, or just doesn't have the right packages installed, then they're not going to be able to run it. So it's a bit of a pain to share. So that's why I prefer in general just sticking with these graphs. But then again, the dashboard format in this case can be very appealing. And then let's go ahead and update our Y range as well. So same thing here. We're just going to swap the X for the Y. And the range is equal to, we'll give it a little bit of space below 0. So we can call it negative 0.01. Remember, these are percentages, so it's from 0 to 1, not 0 to 100. And oops, we want a list, not a tuple. Negative 0.01 to 1.01. Let's see how this looks. And that looks a little bit better. I prefer to have just a little bit of space over our top tick right there. Again, just personal preference in terms of formatting. So we have pretty much everything set with this graph. We can, we can play around with this max value. We can change it to 500, zoom out a little bit. We could change it to 50 if we want to zoom in. And the last thing we want to be able to do is play with our baseline a little bit. So let's say we want to change our denominator from the total number of current registered users by user category to, let's say, current registered users who have purchased at least once. So we want to change up kind of our interpretation of the retention curve. So let's go back up here to where we set our baseline. And then just make sure we don't overwrite anything here. I think we can start here. I believe this should work, but we'll test it out. Baseline equals 1. Come back up here and say run all below. And that works. So our first option here is 1. So we have all at 100% of these users have purchased at least once because we changed our baseline. And so now our interpretation of 3, for example, is of users who have purchased at least once, 70% of free users purchased at least 3 times, and 85 and change percent of premium users purchased at least 3 times. So then we can go back and say the same thing. Let's say, where's that cell? Find our baseline. What if we want to change it to, let's say 4? Yeah, that'll cause an error. So I have to come back up here. So again, say run all below, and that'll work. So now 100% have made at least 4 purchases, and then let's say, let's interpret 15 here. So of currently registered customers who have made at least 4 purchases, we have 61.5% of the premium users will go on to purchase at least 15 times compared to 38.4% of the free users. Let's go back up here and we'll set our baseline to, we'll set it equal to 1. I think that's a true user retention curve. So again, of users that you converted into buyers because they purchased at least once, are you getting them to purchase again? So I think that's the truest representation of the user retention curve. So I'll come back up here, run all below. There's our graph. And now let's actually download this file because we want to be able to download this graph while maintaining the nice interactive functions here and be able to send it out to our team. So let's actually bump up our max val again. I'd rather have this high because people can always zoom in later. So we'll leave it at 900 and allow people to zoom in like that if they choose. And then we're going to run this line of code here. So we're going to bring this in. Let's uncomment that and then comment this in. So this is a line of code to download our figure as an HTML file. So we can obviously download a figure as just like a PNG, just as a static photo, or we could take a screenshot as well, but that's going to lose the interactive function. So we're not going to have the hover template, we're not going to have the zoom, and we really want to keep that. So this line of code will download our figure as an HTML file, which will keep the interactive function, and it's in a file that we can actually send out to stakeholders, and they won't need any code or any sort of special software to open it. So this is going to download the file. Let's change the file name. We'll call it, say, customer retention curve. And this is going to download the file to my desktop. So you can just copy this line of code here for when you want to download your own HTML file here. So it's going to download to Alex is the name of my just user profile on my laptop, to the desktop, and then this last part is the name of the file. So let's run this line of code. And then I will go to my desktop, pull up that file, and make sure everything looks good. So quick little addition to the code here. We have to, in our file name, we also need to specify that it is an HTML file there. So that little quick addition will give us our curve. So this is the opened HTML file. Oops, open this back up. And this is our file. So we can share this with our stakeholders and they can analyze the curve. And this gives us an idea of how the premium versus free customers are performing, how well we're retaining them. And this can give our stakeholders a lot of information about how to react to the changing business climate. So that is the end of the tutorial today. Please leave a like if you enjoyed this full project video and subscribe to the channel for more data analytics content in the future. Thanks for watching.